Hello friends, welcome to our YouTube channel, and in this video we're gonna see the sub-assembly for the bridge, default bridge that we have here in Civil 3D. Okay, we have actually two default bridge sub-assembly in Civil 3D. So we'll use this and we'll try to put this here and we'll see what are the drawbacks of those two. Okay, so first of all, what we have to see is here right now. I just elevated this profile, changed the profile, and made some space. The depth, made the depth enough so that I can justify a bridge here. So let's see what's the depth. So for that, we're gonna just select our profile view, and up here you will see add view levels. Okay, and then click on the drop down here, and one is the station, then another is the depth. So we need the depth, so we're gonna click on the depth, and then from here, maybe somewhere here, I want to see this part from this to somewhere here. Okay, and how much is it? 13.88 meters. Okay, that's good enough for a bridge. Okay, and it is going to be, as per this particular, it is going to be a very long bridge from 260 around. Okay, or maybe 200. Let's check the depth here. What's the depth here? So we select again and then check the depth here. What's the depth? Almost, it's like 4 point something meter. Okay, so oh, control Z. Just delete this one, and here also around 4 meter. Okay, so maybe we can start from where here, like 240 or 260, depending upon how much you want, like, and also the soil conditions. Okay, if you find a good rock here, bedrock you have, then you can accordingly decide it, and also depends upon the river, the river here, how the river flows. Here right now we don't have a river, but the direction of the flow of the river also. Okay, so we have to check these conditions. For right now, we are only concerned about using the sub-assembly, default sub-assembly that we have for the bridge. Okay, and we will somewhere start from two, maybe 300. Let's start from 300. Let's simplify it and reach till here. It's around 880. Okay, so from 300 to 880. Okay, cool. It's going to be very long, 580 meters long. No problem. And right here, as you see, this one, it's going beyond our the surface that we have, so that's why it's not visible. Okay, the corridor is not visible anyway. We don't need it as the bridge is going to be here. Let me just remove this part also, or just keep it. Okay, from here, it's 300 anyway. From here we are going to start the bridge. Okay, no problem. So first we have to create our sub assembly. Okay, so let me create new assembly, create assembly from the top, and I will just name it bridge bridge assembly. Okay, and we're gonna say okay, and I'm gonna click somewhere here. Okay, now in the tool palette here and the bridge tab, we have two. So let's click the first one here, bridge box girder. Okay, and then I'm gonna just click it here, so it will snap to the center. Okay, and this is going to be the crown level. Okay, so make sure it's like that. Okay, and you have these two stuff here, like the cross barriers at the ends. Okay, jersey barriers at the end, and this is the dimensions. We can edit a little bit. We select the subassembly and go to the properties. Here you have left lane width. You can have a different lane width. Okay, so we can, it depends upon your road. So right now we'll just put it something, then later we will adjust it. We can adjust it later also. So I can just say 3.5. Okay, for us I think it's 3.5, and here also this one is 3.5, and similarly, oh, sorry, this one is also 3.5. Enter. And similarly, the outside lane slope is, it depends on how much is both side or single side. It depends upon where your bridge is. It's in a curve, or the way it is. So it depends upon that. And then soffit depth. Okay, so this one is 2 meter right now. So we're gonna reduce it, maybe make it Maybe make it 1 meter. Okay, but the bridge, it depends upon the span of your bridge as you design it. Okay, so for that, and s depth is 0.515. It's plunge depth is this one, no problem. Okay, and overhang width is how much? Let's see, this one is from here, I guess. Okay, this one is from here. We can verify it. We can just annotate and check it here to here, how much it is. 2.3. Okay, and from here to this part is 3.5. So I think this particular is 1.2 meter. 1.2 meter here. So this is the overhang width. Okay, so you can change it. So this one can be changed. Okay, and it is also girder width. Okay, so girder width of the girder, how much we can output. So that you can have. Okay, so this is here. You can just check it. It's here. It's this one. Okay, so this one is the girder width. Okay, we can stick it. So keep it here like that. Okay, so you see, so these are all customizable. You can reduce it or increase it. Okay, and then overhang width will be also okay, and then you can include or you can omit the barriers. We need the barriers, so we include the barrier. Okay, and then you can adjust the barrier dimensions also. There are A, B, C, D, E. Okay, and you can change it accordingly. And if you want to see what these are, then you can just Google, just go to the website and just put it bridge box girder one, and or we just we are here and we can say F1, and it will show you this part, and you can see all of the what it is. So even for this barrier, all the details are available. Okay, so this is how you can see everything and understand it, and accordingly you can dimension it. Okay, so every explanation is here. Okay, cool. So now we just keep it like that. This is just an example. So we keep it like that, and yeah, we check our how much is our width. So let's take this one here. I don't know how much we put it. 3.6. Okay, so we can change this to 3.6. Okay, it is 3.5. So this should be more. Okay, so we have to check how much the bottom width is. Okay, the bottom of the barrier is, it's 0.315. Okay, so this should be more than that. Okay, so we have to increase it to how much? We have to say 3.5 or 3.6 plus we have to say 0.315. Okay, and that's it. So it should be like 3.915. Okay, 3.915, and this one also 3.915. Okay, so now all set, and now we have to implement this particular assembly there. So we click our corridor, select our corridor, and go to the corridor properties. And here now we have to actually split this part. First split this part, and then we will implement it. So split the region, split, and we will start from where? From, we just gonna say 300. Just write it, or you have to select it. 300 to where it was 880, I think. Okay, so 880, 880. Okay, and so enter. Okay, as I see, we even need here, but for this example we just keep it like that. Okay, now hit escape a couple of times, and then we get out of the commands and keep this one is selected. Go to the corridor properties, and then we're gonna see which is that area, this particular area. Okay, I can even rename it, so we just rename it for the bridge. Okay, and now we have to, it's a basic assembly right now, so we have to change the assembly. So click on this, and then you have a option to change, and we have either drop down or you can select. So from drop down I will select bridge and say okay. This is the advantage of naming everything, in Civil 3D. Maybe I'm thinking about creating a video uh, in which I will show you how the naming is very important when your project is actually uh, complicated. So it will be very easy to put everything together when the project is complicated, and a naming, there should be a naming system so that you are able to identify everything properly, and there's not a problem. Okay, so we'll put the bridge, and everything is fine, I think, and say apply. Okay, and reveal the corridor and say okay. Okay, now you see, as these, these were linked to the dynamically to this, so this is being built. Okay, cool. But you are seeing maybe there's a bit of distance, because of maybe probably there's a for the frequency. Because of frequency, you are seeing this gap. Okay, so we select the corridor and go to the corridor properties, and here they are there, but only problem is the frequency. Okay, so frequency is 20 meters. Okay, I can make it to maybe it should be lesser, so maybe I put it to maybe 1 meter and 1 meter. And even there we don't have spirals, but no problem, we just put it 1 meter for everywhere and say okay and say apply, and that will solve the problem. Okay, so okay, so now this is fine, I think. Okay, so that's fine. Okay, let's see how it appears. We just have bridge here. Go to the object viewer and see in the view how the it is. Okay, how this appears. And even let's try with driving. It's easier for us to identify anything that we have. Okay, so we go there and go to the drive mode, drive, and select the corridor. Okay, alignment, and we're gonna use the crown and say okay, and let it be ready for the drive mode. Okay, and we directly go to that particular location. The chain is I want to go to, it was 300, so I'm gonna go to 260. Okay, and 260, from 260, or maybe even earlier, maybe 200. Okay, so we can see it. Okay, so let's try and see. Okay, so you have the barriers here perfectly aligned with the bridge. Okay, okay, so let's close this, and we will be back to our view. And then you see, you have already been able to, but in this you don't have any other, you don't have substructures, you only have the superstructure. And if this is fine, you can put other things like the um, bearing plinths and everything. You can just put it here. Like for this, you can have, if you want a bearing plinth here. Okay, so we can just create a bearing plinth, maybe a rectangle, a small rectangle. I'm gonna just create a small rectangle like this. Okay, and then it should have, above it there will be a bearing pad. Okay, so you just do it according to your design and requirements. Okay, so just I'm putting it this like this, and then we're gonna create subassembly from this. Okay, so we can create a subassembly, create design, and then create subassembly from polyline, and we just select this polyline. I'm gonna create this as a subassembly that will be bearing uh, plinth. Okay, and say okay. Okay, so this one is here. Now we have to move this particular modify origin. I'm gonna put it as a center, and you see here how much below than that. So you have your bearing pad. Okay, so once you have your bearing pad, you can put it accordingly. Okay, so let's say we have our bearing pad at maybe it's like, let's say our bearing pad is 75 mm. Okay, so from here we locate a point which is 75 mm, then we will add this there. Okay, so for this we just keep it, and then we have to add it. Let's add it. So we select our subassembly and then say add to assembly. Okay, and then we add it somewhere here, and just see, you see it's here. Okay, so we have to bring it down. So we can just drag it. Okay, and bring it to move. and move it to, see, we have to select this particular small subassembly and say move, and from here we can move it to this point. Okay, and then from here we have to move zero point 0.7, 0.075 in meter. Okay, so move it by this point to 0.075. Okay, and that's the point where the bearing plinth will be. So this is how you can determine, this will be useful in determining the level here at the bearing plinth top. Okay, okay, so now we have put it here. Now it's added already to the our assembly, bridge assembly. Now what you can do is we just have select the corridor, select the corridor and reveal the corridor. Okay, and this will reveal the corridor. Once it's reviewed, you have to go to the cross section to check it. So it's 300. Okay, so we go somewhere. Oh, okay, here you see it's there. Okay, and even for this, your the super elevation has been applied. Okay, you see the super elevation has been applied. So it's normally, here we have curve like this. Okay, so the bridge is on the curve. You mostly you have to, avoid such curves, complex curves in the bridges. It should have been, straight line. That would be better for the bridges, to avoid such complications in the design and the construction works. Okay, but here we have, so you see like how it is responding to your, it's just for demonstration purpose. So how it's responding to the super elevation that you can see it here. Okay, and it is adapting accordingly. Okay, so from here you can find your plinth level. Okay, so you select your cross section that where you want to find, and on the top you have the option add level, so offset and station. So now where I want it here. So okay, here. Okay, I have the offset is 0 at this center line, and the elevation of the bearing plinth at the top is this. So okay, so this is how easily you can, determine the elevations of the bearing plinth. Later in the video, we will see this one is default, that default subassembly that we have. We will build a subassembly, and then I will show you how we can do it properly. Okay, so that's all for this video, guys. This video is actually becoming long, so thanks a lot for watching. Like, share, subscribe to our channel, and see you guys in the next video. Thanks a lot.